So let's start. Hello, everyone. Good afternoon. I'm glad that you decided to join to listen the introduction for load testing, which I am going to describe in the next 25 minutes. However, at the beginning, please allow me to introduce myself. My name is Łukasz Nowak. Although lately I am usually called a senior front-end developer, for the last couple of years I realized that I am just getting more and more into automatic testing of front-end applications. Together with friends from my company, the teammates, we are usually authors of quite complex and complicated testing suite, including integration, functionality, some accessibility and stuff. I didn't mention load testing here. This is just because load testing is considered some kind of a niche in terms of testing, rather peripheral type of testing. And I see, that this subject is not very sexy just because I think that it's like 16 people here. That's kind of obvious just because for most developers, basically load testing is something that they do not have to write at all. And even if you are familiar with load testing, basically it is not your everyday testing you wanna perform. Why is that so? Well, in order to understand that, let's head to the world as it was at the end of the 20th century, which is obviously a quote from Morpheus, from Matrix, just because this is the markup for those days. So how internet looked like back in the days. Imagine yourself that Google was not a leading search engine back in the days, just because Google was considered an emerging company, and they offered some kind of a geeky tool that not everyone was willing to use to. Imagine yourself that basically there was no video streaming, just because if you were trying to download a single MP3 song, it took you 1 hour if you were lucky. And I am talking about downloading MP3 songs. Right now, we might be a little bit, let's say, ashamed about that. However, that was the history of the internet. That's what was internet for. So as you can see, basically the time perception back in the days was something completely very different, just because the internet overall was very slow. The main reason for that was that just because it was the bandwidth of the internet connection was very low, but also we, in terms of a technology, was not very helping that with as well. Most web services was quite monolithic. There was no dedicated layers of back and front end optimization and stuff. So for example, if you were sending some post request, then server was able to handle this request, ending up with some data being added to the database. And then in return, we saw the header, redirect header with some new URL. What does it mean? Well, browser was navigating the user to the client to completely new URL, and then another connection to the server appeared. So the server was getting the data from database back. Then this data was injected into the template engine, and then entire HTML markup was created. And entire HTML code was returned to the client. Sometimes the pages was quite big, so the HTML markup was also big, and imagine yourself trying to send this amount of data as a return view through very low bandwidth internet. So basically everything was taking a lot of time. This was very perfect moment for us to perform some optimizations. The most important one was to make the internet going faster, right? But the other one was the technological improvement over the technology. In order to do so, there was a necessity for us to create some kind of metrics to understand whether we are going right direction or not. And this is perfect space for load testing. This is just because load testing are taking care of measuring how performant the system is or the resource is. In terms of resource, I am talking about anything fetched from internet. It might be some, I don't know, fancy picture from your holiday fetched from content delivery network, or most usually it's supposed to be some kind of an endpoint exposed by backend component. So load testing allows us to create some statistic, how fast the endpoint is responding, I mean the response time. We measure this metric just because it is very good metric to encapsulate all pain points of performance. Like, for example, how fast is the data traveling to the server? How far is the server? What is the performance of backend component? How easy we can get some data from database and stuff. So basically, yeah, we have one number which basically tells us a lot. Load testing also is able to provide some information what is the status of our service. This is just because whenever we perform some API call, we create some logs on our server side, and investigating those logs, giving some information how our system performs overall. There is one kind of funny situation, funny thing connected with load testing, just because load testing is not only one kind of test. Honestly, this is rather a group or a bucket of different scenarios, and they provide answers for completely different questions. During this presentation, I am going to describe 4 most popular or most important, in my opinion, kind of load scenarios, and sarcastically saying the first one is called the load testing. In order to perform such tests, we have to create one definition. The definition is going to be performance. So let's say that our tested endpoint is considered performant whenever it is able to answer within 100 milliseconds or even faster. Once we have it, we want to measure how many users can hit this endpoint at the same time, and this endpoint is still going to be performant. So let's assume that our endpoint can serve 100 virtual users. So we are performing this test, which is very well described as a picture, where on a horizontal line we have a time of execution of this test, and on the vertical amount of virtual users hitting the same endpoint at the same time. So as you can see, we are starting from 0, we are ramping up to something like 60 or 70 virtual users, then we stabilize the traffic, and then we peak to 100 and slowing down a little bit after that. After this test is finished, we can sneak into the results, and if the average response time of this tested endpoint usually was below 100 milliseconds, that's good. I mean, we just have our goal, right? But this is not the end. This way, if we know if the endpoint is performant, we can double the traffic and perform the load testing once again. After several iterations, we can measure how many users we can serve at the same time. And this is what we call a endpoint throughput. This is very important just because as fast as we know the endpoint throughput, we can head to another testing scenario, which is stress testing. This test is a little bit different just because initially we are getting to the throughput of the endpoint, and then we stabilize the traffic. After that, we are putting a little bit more tension, and we are doing it very slow. So we are doubling the traffic. However, we are doing that very slow and stabilize after that. Of course, we can perform several iterations of that increase. And after that, we want to slow down. We want to cool down the traffic very slowly also. It happens just because stress testing is simulating something which we call Black Friday traffic increase or something like that. We want to increase and decrease the traffic very slowly just because we want our infrastructure to react on this traffic increase. We want some new pods or items of our infrastructure to create, and then we want to know whether the infrastructure is able to scale up or even scale down at the end of the test. Obviously, measuring the performance is most important right now, just because we know that the performance, to be honest, well, it's going to be a little bit shitty, right? It's going to be above the numbers we want, but we don't care. The most important information for us is whether the system is going to be able to handle this traffic even performantly. Just because if our business relies on things like Black Friday, we want to be sure that we are available on the web space. Everyone knows that during Black Friday, internet is slowing down, right? So no one cares. They want to buy things anyway. So as you can see, yeah, The DNA of this type of testing is predictability, putting tension very slowly, and basically, yeah, doing everything quite slowly and quite easy. The DNA of next testing scenario is, however, something completely different. This is the spike testing. So initially, we are warming up the machinery. We are doing the everyday normal traffic. And then we are starting to hit with some incredible amount of traffic. Like, for example, let's say that the throughput was about 100 users. And then let's start hitting this endpoint with something like 15, 18, 20, 100 users at the same time. We don't want to prepare our infrastructure for such traffic. We just want to hit very hard, very fast, very strong, and just, pull back very fast too, in order to understand what will happen after that. This kind of test is simulation of DDoS attack. So basically, we really don't care of the performance of our endpoint, just because the endpoint is not going to respond with such big traffic, right? Also, we don't want to measure the performance. We want to break the system. We want to destroy our infrastructure just because it's not going to be able to handle that traffic. And that's okay for us. This is just because we want to perform some kind of a post-mortem investigation and understand what is happening with the system, whether the system is able to remediate itself after the disaster just finished, right? If that happens, that's okay. We working on some kind of automated environment. If that does not happen, it means that our DevOps has to be on a call and they may expect some task to be performed something like 2 or 3 a.m. Saturday night, very unpleasant moment for, working. So yeah, this kind of testing is kind of crazy story, I would say, crazy thing. And this is completely opposite to the last type of testing, which is soak testing, the most boring and most time consuming of all of them. This is just because we are hitting the endpoint with a expected throughput, and we are keep doing that for next couple of hours. So yeah, nothing fancy, but the bad thing is that basically most important, most interesting outcomes appear at the end of this test. This is just because with this test, we want to simulate several years of this service being in operation to our clients. Why we want to do that? Well, if you have some service which works for several years, then after those several years, there will be very little people remembering what was that service all about. Like quoting the Monty Python sketch, it's going to be a machine doing ping, just because no one will ever know what is it all about. So once we're doing this, several hours of hitting the endpoint, we can identify whether there is some memory leaks, or maybe we have some poor caching policy, or maybe we overlog things and do not clean that. So basically, at some point, we may get to running out of quote, which obviously is a problem too. If no such things appear, it means that basically the service is self-maintainable, so it will lower down cost for your company, and basically this is a very good thing for us and for company. And that's it from the theory point. So right now let's head to some practice and let's check how can we perform testing. And maybe I will move myself here. This is just because I want to say good afternoon, everyone. My name is Grafana K6. I am a tooling dedicated to write load testing. Just for your information, this guy, the author of this presentation, is not connected with me or my owners anyway. He just found me somewhere in the web space and started to experiment with me. He found me interesting tool, mostly just because creating test scenario happens in JavaScript code, which is very good for front-end developers, I would say, or at least very convenient. And thank you, K6, for introduction. I take it from here. If you want to work with K6, you may install the software several ways, like, for example, through command line. If you want to add K6 into your pipelines, you may get some installer dedicated to your operation system, and in a matter of 3 or 4 clicks, you have the machinery on your local machine. When it comes to test scenario configuration, it is really a matter of several lines of code. The most important is obviously the definition of stages, which reflects the graph I displayed several slides before. In this case, for example, we obviously starting from 0 point, and in 3 minutes, we are going to have 60 virtual users hitting the same endpoint, and we want to keep this traffic for next 8 minutes. When it comes to default function, basically this is our test. We are defining the URL we want to perform those tests against. And also we have the check function below. However, I am going to display this function in a few minutes. If you want to run this test, basically, yeah, that's a one-liner on your command with an address of a file where we define the test scenario. And after several minutes of test running, we see results with a lot of interesting numbers you probably don't see just because the font is very slow. So let's magnify that. And I just wanted to say that practically most important figure is request duration. This is the response time. So we have a lot of interesting information, like, for example, the maximum response time, minimum response time. However, from my perspective and my experience, the most important is average response time. This is just because when it gets to amount of iteration fired during this test scenario, it is 13,000, which is a lot. So the average seems to be a good metric for us at the end of the day. Yeah, the check function. As long as basic statistics are quite cool, we are able to create our own statistics too. For example, we can fire up the check function, and then we are able to understand how many response was correct, or some Kabloomi 400 response or something like that. We can export statistics into some JSON or CSV file, adding it as a artifact of job on our pipelines, but also we are able to connect with some external services, like obviously Grafana is our first tool of choice just because it is integrated with K6 as they are owners of K6, but also you can integrate with Elasticsearch, Prometheus, you name it, and probably you have it just because K6 is very for integrations. When it comes to K6 performance itself, although the test scenario are written with JavaScript, the core engine is written in Go, so it is very performant language. And I found some statistics saying that K6 is able to handle 30 up to 40,000 virtual users on the same time. When it comes to local machines, yeah, we are able to run tests with several thousands of users. CPU should not be a problem. RAM might be a little bit problematic just because each user requires 1 up to 5 mega RAMs. But from my experience, when we are running tests locally, basically this is some kind of investigation or experimentation. So you don't want to run tests for several thousand users. Probably you will run tests against 100 users or something like that. And that's it from the theory and the tooling, just because this is only introduction. I hope that you will get sexy with load testing. You might feel fancy to experiment with that. However, my final impressions for using K6 for last couple of years was that I have fallen in love with K6 for its extremely low level of introduction to load testing. Like installing is 3 clicks, the trivial test scenario is a matter of several lines of code, and boom, we are in the matrix already. K6 is very configurable. So for example, the examples of test of scenarios was quite trivial on previous slides. Also, you can perform very complicated client journey where, for example, you want to test against several thousand of clients. You have to authenticate those clients. So first of all, you are hitting some authorization endpoint in order to get authorization token. Then you are putting this token into the header or cookie or whatever, and then you perform series of different testing over different endpoints. So it really is up to you whether you are going to create difficult scenarios or maybe you want to have have some single one-shot smoke test for one endpoint, or you want to perform some experimentations, which is very good in terms of a K6, just because this is free tooling, so you may not need this, enterprise services offered by Grafana or someone else. In terms of recommendations, I recommend to use load testing for rather mature enterprises, something like financial companies who have some obligations against some regulatories, like the one I work for. Probably those enterprises have created dedicated teams for creating some such tests and also environments. Those things are not cheap, to be honest. So that's why I said mature and enterprises. This is very important. If, on the other way, you are contributing with increased traffic like Black Fridays, you want to run such tests just because you want to be sure that you are available on the web space during the initiative, just because otherwise you are going to lose money. Also, we have to remember that actually we are on a war right now, both the real one and the virtual one. So if you are an owner of some critical business or maybe government-related service, you have to prepare yourself on a DDoS attack. So you want to know whether your service is going to remediate yourself sooner or later. And also, honestly, I propose to get familiar with load testing to all developers, even guys like me, like front-end developers, which sarcastically is very true, just because when we go to the modern architecture of software in terms of front-end, there is very thin backend layer called backend for front-end. This layer is responsible of having knowledge which domain-based microservices do they have to communicate with in order to get the data required by front-end application. And BFF layer is usually part of the JavaScript full stack framework. So basically most of front-end developers even are not aware that they are using this approach. And to be honest, we have 3 minutes, so I have some time for our story. To be honest, several years ago, I found load testing very handy for me, just because we were creating some project, and at some point we realized that we are not very performant. So obviously clicking F5 button and just counting 1, 2, 3, 4, 5, it's not a statistic, right? We need some real metrics. So we decided to investigate using load testing. We thought that the integration tree of our ecosystem looks more or less like that. However, this was very not true, just because the company's service was gathering a lot of data from different sub-services, it turned out. So we found that the endpoint exposed by company's service was not very performant, and this was a problem for us. So more or less, it looked like this way. The endpoint exposed by company's microservice was responding with more than 1.5 seconds. This was just because it's been connecting with some other microservices, and it was returning completely crazy amount of data. And sarcastically, what we needed was only a very small factor of this data. So we found that maybe instead of calling the company's service, we will call all of those services separately. So we had some idea of fix, and we decided to call those microservices. And this is how we did it. I mean, we created very simple, very amateur load testing for the endpoint exposed by our BFF layer. Then we run those tests, and then we store the results on some, data place like Confluence pages or whatever. Then we performed fix, and then we run those tests against the refactor endpoint, and boom, we have proven data that overall performance improvement was for more than 1 second, which was like incredible success story for financial business we worked on. So as you can see, load tests might be completely different. It might be very complicated. It might be run just once when you are deploying new solution, or maybe fired periodically once per several months in order to track the performance of the endpoint. On the other hand, you may just use it like amateurs, and it will provide very, very good information to you to your further investigations. Which concludes my presentation today. I hope that you got fancy into load testing. And if you have some questions right now, I don't know whether we are going to run questions right now or later, maybe right now. I saw some hand rising.
Yeah, so I wonder what environments are you running the tests on? Are you running on production or have dedicated performance testing environment?
I think we have microphone, so if you might repeat the question, which is muted.
Work? Okay, now it works. So I wonder what environments are you running the tests on? Production or dedicated performance?
You really don't want to run spike tests on a production, right? That probably answers the question. No, to be honest, when we experimented, we rather used some mid-layer like QA environment, like something, there was the very dirty environment, then there was system integration environment, then there was candidate, and then there was production. So it was somewhere between system integration and the pre-production. However, when it comes to identifying the performance, usually in big enterprises, there is additional environment just created on the side. Probably it's supposed to be the quality of this environment supposed to be aligned with the production, and then we are hitting this non-functional environment just because this is the one we can destroy, right? This is our system. So normally, I would recommend to create some kind of a side environment that you can destroy at some point.
I have a second question, but I'm not sure.
Okay, so thank you. Sorry for making it a little bit too longer. However, if you have any questions related to load testing, testing front end, please feel free to catch me today, tomorrow, or day after tomorrow on a LinkedIn. I will be happy to answer all questions. And thank you.